Hi Year 11, this is going to be a short video going over how to use the compound interest formula. So let's look at this problem. Calculate the future value of an investment at $12,000, 7% per annum for 5 years. So there are our main bits of information that we need, where the interest is compounded annually. So I need to know when we're going to actually add the interest to our principal, to our present value. Okay, so the first thing we do whenever we do these, we know it's compound interest, so let's go and write down our formula. So our formula is the future value equals present value times 1 plus the rate to the power of n. And as in simple interest, the rate's going to be a decimal. So in this one, let's pull out the information that we have. The present value of what we've invested is $12,000. Our rate is 7% per annum, which we're going to convert to a decimal, so it becomes 0.07. And our time, which is n, is 5 years. Now we can do it because the interest is only compounded at the end of each year. So we plug these values into our formula. It equals 12,000 times 1 plus 0.07 to the power of 5. You can put it straight like that into your calculator, or you might want to simplify it to get rid of those brackets. If we put those straight into our calculator, we end up finding that our future value, if you invested that $12,000, would be $16,830.62. Not a bad amount to invest. Now that's fine for when it's values per, where it gets compounded annually, but what happens when we get things compounded quarterly? So with this question, it starts off the same. Calculate the future value of an investment of $6,000 at 8% per annum for 2 years, but this time the interest is compounded quarterly. So this is where it becomes really important to go and make sure you pull out the information that you need. So once again, we have the same exactly the same formula. Sorry about that. Future value equals the present value times 1 plus r to the n. You're going to be happy to know you don't have to remember this formula. It's going to be on a sheet when you have any exams, but we still write it out each time. So our present value is going to be 6,000. I'll do it over here. Present value equals $6,000. And our rate is 8% per annum. So we convert that to 0.08. However, if it's compounded quarterly, that means that yearly rate has to be divided by 4. So over the year, so for each quarter, it's going to be compounded at a rate of 0.02. And over the year, it's going to be 2, 4, 6, 8. You'll get back up to that annual rate. And our time periods, instead of time being years, for 2 years, I'm going to have 2 times 4 times when I'm going to have that interest compounded. So that becomes 8. So have a look. As my rate gets divided by 4, because it's quarterly, the number of time periods I have that I'm getting the interest compounded, I'm going to have to times by 4, use by 4. So that's where they balance out. And let's see what happens here. So I end up with 1 plus, this time, 0.02 to the power of 8. And with that, I can simplify 0.02 to the 8. I put that into my calculator and I end up with $7,029.96. So the key ones with these, work out how many times it's compounded per year, divide that number, or divide the rate by that number, multiply the time by that number. So if it was compounded monthly, you'd be dividing the rate by 12, because that rate would have to spread over the whole year, but you would be timesing your time by 12, because it would be 12 times each year that you get it compounded. You can even get them compounded daily. So then you have to divide by 360 for the rate and times by 360 for the years.